Greenhouse gases are gases that are naturally present in the atmosphere. By absorbing part of the sunlight and heat emitted by the Earth, they guarantee the conditions for life on our planet. The greenhouse effect is therefore a completely natural phenomenon. How does the greenhouse effect work? Greenhouse gases have the ability to absorb far-infrared radiation, that is, radiation with very long wavelengths. Most of the sunlight that reaches the Earth is absorbed by the surface, warming it up. This heat is then released by far-infrared radiation into the atmosphere. Some of this radiation is absorbed by greenhouse gases, and like all natural systems, these gases aim to maintain a stable state. So after absorbing the radiation, they re-emit it in all directions, including back toward the Earth's surface. This process is what creates the greenhouse effect. While this is a natural and essential phenomenon, it becomes problematic when human activities release additional greenhouse gases into the atmosphere, which contributes to global warming. The additional greenhouse effects. Certain gases emitted into the atmosphere are capable of influencing the temperature at the Earth's surface and can cause climate change. They are known as climate forces. Radiative forcing measures the thermal imbalance experienced by the Earth, that is, the difference between the energy arriving on Earth and the energy that would have left if the Earth had remained at 15 degrees Celsius, which is the pre-industrial temperature. When radiative forcing is positive, the Earth experiences a rise in temperature, and when it is negative, the temperature decreases. Greenhouse gases are radiative forces with a warming potential that varies according to the nature of the gas. These include water vapor, carbon dioxide, methane, nitrous oxide, ozone, and NTCFs, which are near-term climate forces. Their global warming potential, or GWP, is generally expressed in CO2 equivalent. This is the quantity of carbon dioxide that would cause the same cumulative radiative forcing over a given period. Greenhouse gases have different lifetimes. Short-lived gases, such as methane, have a short life cycle in the atmosphere and therefore react rapidly with other elements in the environment. They can therefore cause local impacts on ecosystems and human societies, such as droughts or hurricanes. On the other hand, long-lived gases such as carbon dioxide and nitrous oxide remain suspended in the atmosphere for several years without reacting immediately with other molecules. These gases can have long-term climatic consequences, such as rising sea levels or irreversible climate change. The impacts of short-lived gases on climate change diminish over time, while those of long-lived gases are more long-lasting. It is therefore crucial to pay particular attention to long-lived gases, as their consequences are not immediately apparent and act like a time bomb.